Focus, guys. We don't have a lot of time. We gotta finish this all up. Do I need to write down the trig derivatives?
It'd be nice, but
I'll be so quick. Actually, I'm going to write it like this so that you can just read across. Go down. Is it maybe cosine squared? I think that's right.
oh, it's going up.
I want it to go up. You're going to get these tonight in a way better format.
Oh yes, you know.
He's gonna bring it into the testing center and whip it out.
Okay, don't be that stupid kid. Seriously, I've had a couple of students cheat and then tried to blame it on me. If you do that, I will kill you. By nose. Okay, I don't actually know if I can do any of those things. I will be so mad at you and I will never help you again, even if you have to take the class over like 800 times.
That's the definition of
Sine, cosine, cosecant. At that point, just change your major and take a different class. Sine, cosine, cosecant, cotangent. Just don't blame me for you being stupid. Cheating is stupid. Yep. Let's do, are you guys ready?
Yeah.
You gotta be ready. What's the derivative of sine? And then you have to leave the inside function alone, and then you have to take the derivative of the inside function. What's the derivative of the inside? So far, so good? Okay, what's the derivative of cosine? Then you have to leave the inside function alone, and take the derivative of the inside. What's the derivative of this? 3e to the x plus 3x e to the x. The derivative, you had a product rule, so you got the derivative first times the second plus the first times the derivative of the second. You following? Oh yeah, yeah.
Can you do the last, like, inside part?
Mm-hmm. Totally can. Okay. So we're going to do, oh, probably can't move it up because I can't see on the video. I'll be shorter. The derivative of the first times the second plus the first times the derivative of the second. Not actually getting shorter.
Was that a product thing?
Yeah, totally.
Oh, okay.
Product rule. You follow? We still alive? Is there any room in our brains at this point?
Yeah.
You should just teach us like tricks and cool things to help us cheat. I'm just kidding.
No, Elliot, you're really not that funny. You're probably funnier than I think you are, but I don't think you're funny at all. So, okay. We're going to do the derivative of cosine. What's the derivative of cosine? And you have to leave, hey guys, this will help you. The trig function, the inside, never, ever, 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 ever changes. I don't care if you're taking the derivative a million times, the derivative of the inside, the inside never ever changes. Okay, so that has to be the same. And now because it's a product, we have to use the product rule to take the derivative. Okay, you focused? Back on topic? Derivative of the first times the second plus the first times the derivative of the second. Kind of?
Yes.
Fantastic. Now what's the derivative of cosecant? I really need to put a prime on that. Negative cosecant cotangent, right? Now notice that the insides didn't change at all. And then we have to do the derivative of the inside. What's the derivative of the inside? Now, common mistake that I would like to dispel right now. You're taking the derivative of this inside. That's why it's 18x. I'm not taking the derivative of this inside and this inside. Okay, so we're always going off the original function. The derivative of cosecant is negative cosecant cotangent, the derivative of 9x squared, 18x. Are we going straightforward enough?
Yep.
No? Did someone say no? They're not brave enough to tell me. I don't blame you, I've been kind of a punk. Okay, I'm going to rewrite this. This is squared. Man, I was going to be nice this semester too. I don't think it's working. Okay, I'm going to put the squared right there. That is probably the trickiest part, is knowing that you can take it out like that. So now we can do a massive chain rule. Oh, so much fun. So, y prime. The 2 comes down. The cotangent stays. The 2x squared plus 1 stays. Subtract 1 from 2 to get 1. What's the derivative of cotangent? Negative cosecant.
Squared.
And then we have to do the derivative of 2x squared plus 1. So far, so good? They're going to put this negative, and this 4x, and this 2, all in the front. So the negative comes out front. The 4 times the 2 is 8. The x is in front. I have cotangent. So far, that's it. This negative and the 4x and the 2 all combined to be negative 8x in the front. You with me, Elliot? Even though I'm kind of harsh to you? Should probably play nicer. You need to play nicer to me, too. Okay, everyone okay so far?
Yeah.
Fantastic. I'm trying to think of what we haven't covered at all. We did a cotangent. Oh, have we done a tangent? I don't think we did a tangent yet. I did a tangent line, but did I do a tangent? 9 as in a number, or as knowing in German? Well, you know, of course, I speak German fluently. No, sarcastic, sorry. Let's do... Later, guys. So far, so good? Oh, I'm sorry, I restarted the computer so I could actually put your emails in. Because I don't have time to type in your emails by hand.
So we're going to add it on the email, and then do you have hand copies of some of this stuff, or?
You want me to print things out for you because writing it up wasn't good enough?
No. Just checking, because you have a power right there. Let's just check and see what it was.
Those are mine. You may not have them. Everything I do that's extra, I do not get paid for. So if you whine at me, I just won't be nice to you.
Not ready.
Let me just put it out real quick. Okay. Are you guys ready? So we're going to say the 3 comes down. The tangent stays there. And it's squared. What's the derivative of tangent? Secant squared. And then we have to do the derivative of 5x squared and e to the x. Yes? Subtracted 1 from the power? Cool. Okay, I want you guys to notice something on these derivatives. Notice that the derivative of every single cofunction is negative. Derivative of cosine, negative sign. Derivative of cosecant, negative cosecant. Derivative of cotangent, negative. So the ones that are negative is the derivative of the co-functions. Yes?
Why does in this example and in the last example the tangent like stays there, and like when we did the cosine one, the cosine doesn't stay there.
Because it doesn't have a power on it. Follow? Everyone okay? Alright. I'm trying to think of what else I need to show you. Does anyone have a practice test I can look at real quick? Just to look and see if I forgot any concepts. We did limit,